Very good morning to one and all. Happy morning. Welcome to the third day sessions. So today we are going to see three sessions as usual. The first sessions, Dr. R. Chidambaram sir, scientist, CSIR-CBRI. Sir also joined now. I welcome you, sir. I welcome Dr. Chidambaram sir. Yes. Then the second session from NIT Warangal, Dr. Shankar is transportation specialist. So he will deliver the lectures after that Chidambaram sir. And that afternoon sessions, Dr. C. J. Guru, he is from Tamil Nadu, Tindikkal PSNA College. He is a professor. His topic is the sustainable smart materials. So better we can start this day with our Dr. R. Chidambaram sir. I kindly request Ikram Khan to give a brief introductions about our today's chief guest. Yes, Ikram.
Okay. Thank you, sir. Thank you. So let me introduce Dr. R. Chidambaram, sir. Sir is a scientist and a professor in CSIR-CBRI. Roorkee. Sir has completed his graduation from Anna University in the year 2007 and a post-graduation in structural engineering from Institute of Road and Technology in 2010. And PhD Earthquake Engineering from IIT Roorkee in 2016. Sir has international journals and national journals on 14 international journals and 13 conference papers and 5 national conferences Sir has attended. Sir achievements: inventor of grid confined RC element concept, developed the in-core concept in seismic resistance, patent on retrofitting technique, patent on seismic resistant precast connections, it is under process, and patent on foldable house, it's under process. Sir is almost guiding 2 PhD candidates, and the titles are strengthening and retrofitting of RC structures ongoing at IIT Roorkee, and the next one is study on material characterizations, structural behavior and field implementation of previous concrete. It's ongoing at CSIR. And awards and distinctions. So we have a great list. The Best Technology Award awarded by CSIR-CBRI, awarded for technology development in the year 2020. The next prestigious award, IITR Heritage Grant, awarded by IITR Heritage Foundation in the year 2013. The next one more achievement, MHRD Fellowship by MHRD for the PhD in the year 2011 to 2015. And the PhD research in the year 2016. Sir has industrial experience as East Coast Construction and Industries Limited in Chennai from 2007 to 2018. And the projects worked: performance evaluation of state.
Professor, thank you. I think enough. More than sufficient, right? Okay. So let me start my presentation.
No problem, sir. Thank you. The session is yours. Hello, Siva sir?
Yeah, I'm starting. So, very good morning, everyone. I hope everyone can hear me. So, the today topic of presentation. First of all, I would like to thank Professor Rajesh Kumar and Professor Gopinath for inviting me to this lecture, and the principal, Professor Mahesh, for supporting this program and ATAL organizations. So today my topic of presentation is like high performance materials for smart structural application. So generally, what is the need for this kind of materials, and why we have to apply? what the small structural application means. The general structure may be classified in India as RCC and load bearing. Nowadays, we are far ahead of this, like precast structures and like different panel-based structures, that is lightweight and thermally comfort material and very economical too. And then we have pre-fab structures, pre-engineered structures. And even nowadays we are using trussless roof, using the correlation concept. So these are the various advancements in our construction field. Even in construction also we have very, very advanced instrumentations, equipments to handle the construction work. Once upon a time we were using normal mixture machines, now we are using advanced ready-mix concrete almost everywhere, which gives you wonderful quality materials and perfect compactions, many advantages. But still, we are using the same concrete. So, the concrete remains concrete. When we need some additional parameters, such as if you want to, generally when you are transporting RMC concrete from one place to another place, they used to add some retarder, so the concrete will not sit, and it will start its own chemical reaction after 30 minutes or 40 minutes, so that they can compromise the transport time through this. So these are the various requirements in construction field. So according to the required performance, you can choose the different type of materials. So the materials can be of anything. It may be of mixtures in terms of mineral, in terms of chemical. Apart from this, we do have a lot of materials which can be effectively used in construction field. Many of them are practically applicable. Many of them are still in research level. And many materials are quite expensive, so we have to choose the right location to use. So let me cover a few of them, because I'm not going to cover everything, because people will get bored. So first I will talk about fibers, then I will talk about solid forms, and third I will talk about adhesives. So these are the various types of different forms of fibers are available in our country. Generally, usage of fiber is not a new thing to us. It is a very ancient thing, because since our ancient period we are using fibers in terms of using horse hair and the neems and bamboos and etc. etc. So if you look at the old buildings, the roof will be made up of pitched roof, a flat slab based, like a lime based slab, lime mortar based slab, supported by some wooden planks. If you closely look at the wooden planks, that wooden planks maybe would have been made using a palm tree, otherwise a teak wood. If you go to northeast, the entire structure is made using bamboo. The reason for choosing only this kind of material is, coconut tree wood can be used, but it has no long life period. So generally, palm tree wood is preferred for making planks. If you look at any pitch-proof old buildings, there you will find palm tree wood instead of coconut tree. Coconut tree wood can be for shorter period. It's not have much more lifespan. Even though it has a very good example for fiber in post, but the fiber aspect ratio is very, very high in palm tree wood compared to coconut wood. If you take a small coconut tree and cut the coconut tree, you can see a lot of fibers. So, but generally, coconut tree can resist its own gravitational force. That's why if you look at the coconut tree, the bottom will be very larger and the topmost portion will be very shorter. And it has a umbrella-shaped leaf kind of arrangements. When the tree is subjected to a lateral force in the term of wind, the tree will go here and there, here and there. It's like a pendulum zigzag, zigzag like. How it is going when a banyan tree won't go, but coconut tree will go that much of amount of deformation, because it is very slender, and the thickness, the diameter of your coconut tree will be very small compared to the banyan tree number 2, and it is slender, so it will not have a buckling failure. So even without any confinement, it is not having any buckling failure. because there are no axial force, no, only the lateral force is happening. But the coconut tree and palm tree are very subject to a large amount of wind force because it is very tall in nature and very slender. So the slenderness is the advantage of the tree, and so that it can able to deform, displace laterally to a large amount of. The fiber presence in the tree supports all these actions. Otherwise, the tree can't deflect like this. When you come to a bamboo, even small diameter and having very large height, which means the aspect ratio is very high for this case, still it goes to a large amount of deformation because of the fiber presence, fiber orientations, fiber volume of fiber, I can say. If you cut a coconut tree, you can see a lot of fibers compacted with a lot of wooden materials. When you go to a palm tree, you can see large amount of high aspect ratio fiber having a very good thickness, very high thickness compared to coconut fibers. Even that can go into our skin. That means very sharp fibers can be present in palm tree. When it comes to bamboo tree, there you will not have that much amount of core materials. But then core material, the entire tree is supported by the fiber, continuous fiber. So fibers are very unique in nature. When you are trying to use in concrete, we have certain limitations, like we can't use a continuous fiber because that is very difficult to use, number one. Number two, orientation of the fiber is not easy task in concrete. When you are randomly distributing the fiber, you can't expect the perfect oriented fiber. So fiber generally will be randomly oriented in conventional fiber reinforced concrete, and uneven dispersion is possible, not even dispersion. If you are expecting that exactly 50 gram per inch is not at all possible. So it will be a randomly distributed and randomly dispersed fiber, discontinuous fiber, discrete fiber that we have to use. The aspect ratio means the diameter to length of the fiber besides the, which means that will be used to calculate the aspect ratio. If you are using a very large fiber, then your aspect ratio will be very high and it's very difficult to mix. So when you are going for a road construction, we used to go for a large amount of higher aspect ratio. And when you are going to construct buildings, we have to use short fibers because for easy construction workability cases. Okay. And in steel fiber, hook-run steel fiber, crinkled steel fiber, brass-coated steel fiber, even after this, we have two, three fibers, which is generally will not be in the form of exact fiber shape. It's like deformed, twisted fibers are also available. It's like a small plate kind of in shape. And then we have synthetic fibers, polyethylene fiber, PVA fiber, polypropylene, polyacrylonitrile fiber. Natural fibers are bamboo, banana, coir, etc. So what is the need of this fiber? So creative is, what is the importance of anchorage in steel fiber? See, a simple imagination that you have a bridge. You have a bridge. We used to have a bridge to cross. Initially, we used to have a bridge to cross a river. Or if you have a railway track, then we used to have a bridge to cross the. So generally, a bridge is connecting two different locations, which has a discontinuity, I can say, right? For example, if you let us take an example of river. We have a river. On both sides we have embankment, and if we want to cross the river, I have to make a bridge. The bridge will connect the two disconnected area, two embankment area, and will allow the people to travel. Similarly, these fibers are very helpful in transferring the stress from one point to another point in a cracked region. That is a must. So imagine the crack is the imagine the crack as a river, and the cracked region surface is the embankment. If you want to transfer the stress from this point to that point, we have to transfer the stress through fibers. So fibers are acting as a bridge. So that's why we used to call that as a crack bridging effect of fiber. So now, if you construct a bridge without abutment, like no, only the portions, it is not a perfect one. It should be anchored with the embankment. But anchoring is nothing but in fiber is like the end profile or the profile of fiber. So in hook end fiber, the end portion has some deformed shape. With respect to the deformed shape, it will have a wonderful anchorage that will increase the efficiency of your fiber. But in case of crimpled, the shape of the crimpled fiber itself will give you wonderful anchorage. This is called a crack bridging effect. When we use these kind of fibers in our concrete, that will bridge the cracks at multiple levels. It is not a single pointer at the multiple level because it is randomly distributed, randomly oriented fibers. Micro level, nano level, macro level, all the cracks will be bridged by the fibers. It will try to transport the stress from one point to another point. So this is called the fiber crack bridging mechanism. So why I'm telling you all these things when I'm talking about high performance material? So the material is a common material which can be used effectively to improve certain performance, ductility, durability, strength, energy dissipation, crack sealant. So it's called the self-healing property material. So these are the various materials that are available. When you are considering subject to the large amount of lateral force. So our earthquake resistant design philosophy says that we have to go for a strong column, weak beam, so that plastic hinges will form near the beam, not in the joint, to avoid global failure. When you are using soft story, plastic hinges should be formed like the conventional way. It should not form exactly below the first story concrete column to avoid soft story failure. So we have to follow certain IS 1893 guidelines to increase the shade carrying capacity of your soft story building. So when you do all this design procedure and detailing procedure, we can have a wonderful earthquake resistant buildings, but the concrete remains same. So the concrete is a very poor ductile material. It's a pure brittle material. Even when we reinforce with reinforcement, we are increasing the flexible capacity of the member, but instead we have to use certain material which can increase the tensile carrying capacity of your concrete. When your concrete has a wonderful tensile capacity, because when prior to this, they should know why crack is occurring, how the crack is occurring, how the crack is traveling. So when you have a large amount of lateral force, concrete is subject to alternate compression and tension in the joint. So when the applied stress exceeds the tensile stress of concrete, then you can expect a crack. Same phenomena for all the cases. Suppose if my tensile stress of the concrete is 2 megapascal, and the applied stress exceeds 2 megapascal, immediately crack will occur. Till then, the crack will not appear. So when the crack start to grow, when the applied stress exceeds the tensile stress of the concrete in every level of your RC elements, the crack will grow. The crack will keep on growing. That is called when you measure the stress at the tip of the crack, at the opened level of the crack. The tip of the level crack will have a higher stress level compared to the bottommost crack region. This is called a stress intensity factor. Okay. So crack is generally a good sign in RCC elements. If your crack is a sign, like a fever to a human body, crack is a sign that tells you something is happening to the RCC elements. Instead, a building can fail in an abrupt way. That is generally not advisable. So crack is a warning. So if you can able to treat, if you can able to identify the reason for the cracks, then we can easily retain the structures. Apart from that, we are doing a lot of mistakes like poor detailing. We are simply playing with the detailing. We are telling that it is very difficult to go for a closely spaced stirrups near the joint at the plastic location. We are not able to provide a longitudinal anchorage, and we are telling a lot of useless reasons when it comes to construction stage. But we have to. It can possible. It can be possible. Okay, so to avoid all these kind of failures, there are still construction people are not ready to come forward. But research community is ready to go forward. So they have identified some materials and increase the performance of the element even with some construction errors. So this is how a plastic hinge is to be formed. And when you are expecting a plastic hinge at a particular location, there my element is going to have a large amount of rotation. So energy dissipation is going to happen, and damping of the entire structure depends on each and every plastic hinge capacity. Every everything is depends on the plastic inch. So I have to improve the performance of the plastic inch in terms of displacement, in terms of energy dissipation, and in terms of damping, in terms of ductility. So if I want to increase all this capacity in the conventional way, I have only concrete, another one is reinforcement. Apart from this, I don't have any other options. You can go for closely spaced strips. Even then, crack will occur because of concrete. So now the case is comes if I use some fibers, I can able to increase tensile stress and strain. Strain is very, very important than stress. So what will happen here? High strain material can help you to go for to attain wonderful ductility compared to a high stress material. So that is called high strength material, high ductile materials. Ductile material will help you. So if you want to arrest all these cracks, we have to use some types of fibers. That's the first option. So I'm going to talk about fibers in the first portion, followed by different materials. So in conventional fiber concrete, if you add a fiber that is called as fiber reinforced concrete, conventional concrete surplus certain amount of fiber, not more than 2% of steel fiber. If you are using synthetic fiber, not more than 5%, 0.5%, that will create a lot of workability issues. So when you add fiber, I told you that concrete cracks are getting arrested, and generally the crack will not grow very rapidly because of the presence of fiber. So fiber will bridge the cracks. It will not allow the crack to grow very rapidly. Another one is called as fiber reinforced cementitious composite, in which cement, fine aggregates, mineral admixtures, and water admixtures plus fiber. So here I am not using coarse aggregate. Why I am not using coarse aggregate means coarse aggregates are the very big culprit in deciding the dispersion capacity of your fiber. So when you use coarse aggregate, that significantly affects the fiber dispersion property. Number one, it's a main culprit. That's why in conventional fiber reinforced concrete, we are not able to go more than 2% of steel fiber. So what in a study conducted by myself, we have used fiber reinforced concrete and fiber reinforced cementitious composite. If you closely look at the stress strain diagram, you can understand the stress of your fiber reinforced concrete is higher than the stress of fiber reinforced cementitious composite. The strain is 2 times higher than the conventional fiber reinforced concrete. So what happens when it comes to a damage capacity? If you look at the bottommost cylindrical sample, you can identify the different type of failure pattern. Conventional concrete is part, fiber reinforced concrete holds the cracked portion together. Composite is also holding but crack intensity is not much. That is the beauty of fiber reinforced cementitious composite. Similarly, the tensile strain capacity, you can look at the topmost graph. Conventional fiber reinforced concrete tensile strain capacity is just 0.004, the ultimate I'm talking about. When it comes to this, 2%, 0.02% is not an easy task with conventional fiber reinforced concrete. This is why it is called high strain material. Sometimes it can be termed as strain hardening material. Okay, let us come to the flexural case. Flexural, it reaches the peak, then suddenly it gradually degrades. In steel fiber reinforced concrete or any other fiber reinforced concrete, synthetic or metallic. But it degrades, it is not gaining back. When it comes to a FRCs, fiber reinforced cementitious composite, you can see here the difference is like in fiber reinforced concrete, that it goes and it degrades. When it comes to fiber reinforced cementitious composite, it keeps on going like this and degrade like this. So the amount of retention, post-strength retention capacity varying with respect to the fiber reinforced concrete and with respect to, for example, if I take this level, you can see at this point it has been at this point it has been failed, at this point it has been failed. So the difference decides the ductility, toughness, damping, etc. things. So this is the advantage of fiber reinforced cementitious composites. So I'm not talking about fiber reinforced concrete. This presentation talks about fiber reinforced cementitious composites. There are many types of composites. I'm going to show you that discuss about only few things. One is called slurry infiltrated fibrous concrete. It's very old, 1984. Composite invented to resist the impact force caused because of missile attack in United States by Professor Nankar, in which we are not using reinforcements, we are using only steel fibers in higher volumes. In conventional fiber reinforced concrete, you can't go more than 2%. Here you can go more than 5% to from 5% to 30% of steel fiber. It depends on your economic criteria. So it depends on the requirement. It's one of the high ductile, high impact resistance, high toughness, high energy dissipation, high damping, etc. Whatever the property you want. 100 megapascal, just like this. 100 megapascal concrete you can easily attach into this. And the fluxion strength to compression strength ratio is very high. It's unimaginable. Okay, these are various advantages of this SIPCON, in which the fiber will be randomly oriented or perfectly oriented in a layer by layer by layer, and then slurry will be infiltrated, and the second layer will be happened, slurry will be infiltrated, the third layer will be happened, again slurry will be infiltrated. So this is how we have to make. So it has a lot of restrictions, like the formwork should be plug free, it should be leak free, number one. So perfectly made a formwork, number one. We should not use compact vibrator to vibrate this. A perfect small amount of vibration has to be done. If your slurry is infiltrated improperly, slurry is the backbone of your SIPCON. So if it is improperly infiltrated, then you can't attain the desired performance. So there are a lot of limitations. Apart from this, it has wonderful and construction using this composite. If you want to make a beam column, then this very critical things. So wherever it is possible, like if you want to make some impact resistant slab panels, can be easily made using this. But when you want to try to use this, nowadays we have some advanced instrumentation and equipments to dispose the fiber. Then now we can try, but the orientation of the fiber is very difficult. Because in SIPCON, fiber orientation place, say if it is a perpendicular to loading, parallel to loading, depends on the orientation, the performance varies. If you look at the stress strain curve, one stress strain curve says that parallel to loading shows lesser stress and strain compared to the perpendicular to loading. Perpendicular to loading means you can look at the second image. Here fibers are oriented perpendicular to the loading. Here fibers are oriented parallel to the loading. So with respect to this, the performance varies. So when it comes to a beam, the fiber should be oriented perpendicular to the loading. When it comes to a column, it should be again perpendicular to the loading. It's not to the parallel to the loading, because gravitational force is there. So you may ask, so what will happen when it comes to lateral force to the column? Yes, of course. That's why in column it should be randomly oriented. The performance of the randomly oriented is also different. So tensile behavior is wonderful. Now, how can we do a SIPCON testing? Means, like you can't make a cube like a conventional way. You have to make a prism and you have to cut the prism into a cubical form. We have to do the testing. That's the right way of testing. So if you look at the internal face, you can see this image, the first image. This is the cube specimen we have dismantled from. We have taken the code from prism. This is how the internal structures will be. Even with the perfect orientation, perfectly made, you can see here exactly in this portion, fibers presence are very less. Even with perfect, I have tried my maximum effort in making it a wonderful quality, but still there are human errors. It's very difficult to control it on the site level. At the lab level, it is very difficult to level. When it comes to site level, it is very difficult. Okay, so what is the advantage? So we can see in the second image around 1 centimeter of compression. So the sample expands laterally. Sample expands laterally. Yes, a square cube becomes a rectangular sample like this. Okay, so how it begins under bending? There are no reinforcements. Only fibers are. If you look at the cracking pattern, wherever the fibers are not present, and it travels like this. It's not like the conventional way. Not like the conventional. Conventional way means you can expect a crack like this. Okay, But in this case, it is completely different, and it is following the path of weaker points. Weaker points means instead of crack is traveling like this, the crack is traveling like this. Try to find out the weaker point and travel like this. So same thing can be observed like this here. So these are the advantage of SIPCA. SIPCA is wonderful material. If you do a small mistake, your SIPCA will become like this, and it's one of the, you can't get any desired performance from this. So these are the limitations of. Next one is engineered cementitious composite, developed by Professor Victor C, in which he has used polyvinyl alcohol fiber of 2%, fine admixtures in terms of fly ash, DGPS, microsilica, etc., cement, sometimes sand, sometimes no sand, and then fiber, water reducing admixtures, high range water reducer admixtures. There are two admixtures. Water reducing admixture means water content, for example, if I want, instead of 0.5, if I want to use 0.25, then I have to use water reducing admixtures. Then high range water reducer, and that also to be used. And to disperse the fiber, and fiber segregation should not be happened. So many things are there. So if you look at the articles published by Professor Victor C and his students, you can identify a lot of properties of ECC. And if you take the sample of tension sample, you can see that after yield, the stress is going like this. This is called strain hardening. Strain hardening, getting strain hardening is not an easy task. So this is the conventional failure. This is called strain softening. This is called strain hardening. When you apply the stress, when you apply the force, after the yield, with respect, the stress is increasing as the strain increases. Stress is increasing as the strain increases. Under tension, getting the strain hardening is not at all easy task, like the conventional reinforcement. Okay, so the ECC is providing this, and you can see a prism deforms like this. So that's why Professor Lee calling this composite as a ductile or bendable concrete. Bendable concrete. So now you can ask me, can I use this in building? Yes, of course you can use this in building, bridges, dams, everywhere. But the condition is it's not economical. So wherever the demand is, there we have to use. Wherever the demand is, for example, if you want to have a tall structures, there you can see exactly, because a coupling beam has a lot of demand for flexible capacity and shear capacity and ductility capacity. So we can use this, number one. And when you cross a bridge, one span to another span in India, you will feel a certain amount of vibration, because the gap between the span creates that much of vibration, because we are not treating it perfectly. So what they have used here, exactly between the span, they are used to this ECC. They have converted the connection like this, and it becomes a wonderful smooth lines. And then you can use this kind of materials, retrofitting materials in ECC, in bridges, dams, buildings, etc. things. When you are using this kind of composites in the joint region, you can eliminate the need of closely spaced stirrups, and then you can increase the shear carrying capacity, energy dissipation capacity, damping capacity, damage tolerance capacity. So your building will go for a larger amount of deformation and with significant amount of damage, so that it can be retrofittable. Another one is called ductile. Ductile is a branded name, not a patented product. It's a branded name. It's called ductile. Ductile concrete is called ductile. Strength can be 240 megapascal. Flexural strength will be 45 megapascal. So it's a very, very high strength material, high ductility material. So what is the advantage of high strength and high ductility material? This is the mixed ratio of this. You can look at this. This is the steel I section, and the I section is made using of that ductile composite. Now, a small 25 mm thick slab is carrying the load of a car. That is the advantage of your ultra high performance ductile composites. So, how it works generally? When you are going for normal concrete, you have a coarse aggregate, you have fine aggregate, and a lot of pores are present. Pores, these are the pores. These pores are generally makes the concrete weak. When it comes to this kind of engineered cementitious composite, ductile, or any kind of composites. This is fine aggregate. The pores are filled by fine mineral admixtures at a micro level, nano level. So it has wonderful. This is almost a void-free composites. So when you apply axial force, the minerals are not dislocating because of force, and it is providing you wonderful resistance to the applied stress in terms of tension, in terms of flexure, in terms of compression. Apart from the structural purpose, it can be used for architectural purpose too, so that we can able to reduce the thickness of any material required, and cross section is also can be reduced. Right. Next one is called slurry infiltrated micro reinforced concrete. So what is called micro reinforced? This is almost equal to SIFCON. But in SIFCON, we are facing trouble in keeping the fiber orientation and many things. So in SMRC, what they have done, they have cut a lot of steel wire mesh. Steel wire mesh. Just give a sec. Lot of steel wire mesh in a desired orientation, and then slurry will be infiltrated. Okay, this is how. In addition to this, if you want to add fiber, you can add the fiber. So concrete can be pumped or poured like this. It can be filled, so your composite is ready for. So again, these kind of composites are not meant for direct structural applications, because we have to choose the right locations, right purpose, then it can be used effectively. So I told you ECC is wonderful. That ECC is like this, and Ducon. This is called ductile concrete Ducon. They have named like this. You can see the performance. There are two. One is high ductile Ducon, high strength Ducon. So even that is better than ductile. So ductile is a brand name. Ducon is again a brand name for this. Right. So these are the various types of same material. The mesh can be available locally in our country. You can go and find the material in any hardware shops. But how the materials are being used for different applications matters. So when we use this kind of for impact resistance for our army purpose or any for slabs, it can be effectively used than beam joints or beams, etc., etc. If you are using for beams, have you ever seen such kind of failure? You can see the beam fails like this. It's not split into two halves. If you look at this, a beam deformed in such a way, this much amount of deformation happened due to the composite, due to the fiber presence and mesh presence in this composites. So the failure pattern is completely different, and the mode of deflection is also completely different with respect to the composite used. So this is why it has a wonderful toughness and damping material. That's why it is being preferred for impact resistant structures. So now, obviously, when we have different type of materials, we will try to use for our structural purpose. So similarly, this can be effectively used for strengthening bridge piers, columns. So you can make the confinement like this, and then you can pour that slurry. So how a thin slab, even thinner than the ductile composites, can able to hold a weight like this. These are the advantages, because we may think, so these are very uneconomical concept, and it is very difficult to use. No, when you are using this kind of materials, the thickness will be reduced and the cross section will be reduced, so that we can able to save a lot of materials, lot of workmanships can be saved. So this is for a small introduction about the different type of fibers and how we have used in fiber reinforced cementitious composites and right. So now I'm going to enter into a concept called self-healing concrete. What is self-healing concrete? Self-healing means the concrete will not heal. Generally, concrete don't have healing property. There are multiple mechanisms out there, like developing a bacterial concrete. You would have heard about bacterial concrete. When they grow a bacteria, the bacteria will fill the pores, cracks. Okay, that's a kind of mechanism. Okay? That's kind of healing. Now, this is not like this. This is a kind of adhesive-based healing, in which you can see primer and say, I can say it's a hardener. There are two composites. When you go for epoxy, you will have two, hardener and primer. So part A and part B. If you add these two, then only it will become a perfect adhesive in epoxy. Similarly, we have a part A and part B, and separately infilled in the brittle glass tubes or any tubes like capsules, like our normal medical capsules. You can make the capsules. It can be wrapped. It will be wrapped together, and then it will be small amount of cementitious layer will be applied, so that it will have wonderful bonding with concrete. Now you have a prisms or you have a beam. Now what we have to do? We have to spread the. Generally, when you apply a force like this, you will experience a crack from the bottom side because there is a tension phase, right? So we are not going to have a crack, immediate crack in the compression zone. Only in the tension zone we will have the cracks. So we have to place these kind of capsules exactly at the bottommost point, at the bottommost points, like this. They have kept perfectly oriented and randomly distributed cracks, randomly distributed capsules. These are the capsules are having adhesive chemicals into the capsules. So what will happen when a beam trying to getting cracked? So the capsules will break. Now the capsules, it's a brittle material, so the capsules will break. When the capsules breaks, the hardener and primer will try to leak gradually, small. So because of the gravitational force, it is coming down. So when the two part hardener and primer will combine with each other, it will try to penetrate through the cracked surface. It will try to come down because of the gravitational force. So when it because it's very fine cracks, so the penetration will be very gradual. When it met with together, it will get set. So the epoxy or the adhesive will fill the crack internally. So the crack is filled internally. So once the epoxy is filled the cracks, the epoxy will try to set. There are two things. One, after reacting with the hardener, it can mature, or it can able to cure itself. Otherwise, in some chemicals are required some ultraviolet treatment, or when the epoxy is exposed to atmosphere, or it will react with sunlight, then it will mature itself. It will come to its curing temperature. Once the epoxy attains its curing temperature, it will start to mature itself. Otherwise, we have to apply a UV treatment. When you use UV treatment, these kind of the exposed adhesives will be start to getting cured, and it will become a hardened property that will create a bond between the cracked surface. For example, they have applied like this, then they have a number of cracks. And wherever I have done the red color mark, there the capsules are present. The capsules are getting cracked, and they can able to see the epoxy infiltration through the cracks. So once the ultraviolet rays light is passed over through these, or otherwise when the adhesive exposes to the sunlight, generally it is getting matured and it becomes hardened and it connects the cracked surface. This is called, small introduction about called self-healing concrete. So this is how a self-healing concrete works and helps you to arrest the minor cracks formation in the structures. So it is in research levels, and now they are trying to apply in various structures, because there are a lot of questions will come in this case. You may ask me that, so generally epoxy has a shelf-life period, then how can we use? Yes, of course, yes. We do have a shelf-life period for every chemicals. Once the chemical crossed the shelf-life period, then it won't work together perfectly. So we have certain limitations. So we have to choose the right chemicals for this, long life chemicals, and then it should be perfectly bonded together. Otherwise, once the hardener breaks, the primer is not getting braked, then again it is useless. So if you think that I can use a chemical which does not require hardener, no. Take an example of Fevikwik. Fevikwik is when it reacts with atmosphere, immediately it will set, but it has a shelf period of certain days. Once if you keep that with you without opening that, it will get mature. So that also we have to think. So generally, option part A, part B based chemicals are preferred, so similar to epoxy based, but it has a lot of limitations. So a lot of research is going on in this field. So one of the emerging field, and next one is called shape memory alloy. This is actually they have named this alloy as a shape memory alloy. Basically, it is invented by certain persons using nickel titanium alloy. Nickel titanium alloy. They have named as shape memory alloy. I will tell you the exact reason for this image. Why I am keeping this image. Okay, I will tell you in the later stage. So initially, it was a nickel titanium alloy developed by William, but basically, they were discussing about this in a meeting. About that, William is proposing that I have developed a wonderful material called nickel titanium. It has wonderful lot of advantages like this and this and that, etc. things. Initially, he made a small wire, thin wire kind of things. So they have given this wire to different people. So one of the committee member, Mr. David, used to he was playing with this, like, when you have a small thin wire, we used to roll and we used to play with it. And so he was playing. Then he has a lighter and he just simply fired the wire. It becomes straight. He was shocked and surprised. So this later they have understood that this particular nitinol has a capacity to keep its own memory about its own shape. So if you make a shape like SR University using a simple wire, so when you heat it, it becomes a straight. Or when during the manufacturing itself, if you make SR University, and once you when you stress the entire thing, it will become straight. When you release the force, it will come to the original shape. That's why it is called shape memory alloy. An alloy which has a memory about its own shape. That's why it is called shape memory alloy. Okay, so so how it works generally? Nickel titanium is very costly material. So now they have done a lot of research and they have made different type of chemical combinations, in which steel with nickel is quite magnesium is quite economical compared to the nickel titanium. Basically, heat plays important role in shape memory alloy. This is called the shape memory effect. There are two-way shape memory effect and the superplasticity, that is a pseudo shape memory effect. That means when you heat the material, it becomes to original shape. That is one type of memory. If you heat the material, it goes to another shape. That is called two-way shape memory effect. Pseudo elasticity means when without heating or without cooling, when you remove the applied stress, it will come to its original shape. So by heating, you can make it to original shape. By cooling, it will go to another shape, another different shape, that is called two-way shape memory effect. Without applying a heat or cooling, it will come to original shape. That's called pseudo elasticity. Now I will go to the first image. So nowadays a lot of advanced treatments are available. In this case, if you look at the image carefully, there is a spinal cord. So because nowadays you can see a lot of aged person used to become their height becomes short. They used to bend because their spinal cord capacities, they lost their capacity, so it becomes they are not able to, spinal cord are not able to hold them perfectly vertical. In such cases, you can use a shape memory rod tied with your exact spinal cord like this, and that should be a pseudo elasticity shape memory alloy. So when you deform that when you release the applied stress, it will try to come to its original position. So when you deform, you can easily deform, you can easily bend, but based on the property of your material, the property will try to pull you back. So that will give you additional support to you to bring you back to original position. To bring you back to the original position. So that will help us to come to original position. So a person with a deformed shape spinal cord can be used with a shape memory alloy to make it straight. So that's why I have shown you this image. So this is why, this is how it works, one way, two way, etc. etc. things. The reason for this, there are two phases in this material. One is austenite, another one is martensite. So when the high temperature phase, it becomes austenite, and when it comes to a low temperature phase, martensite happens. So this is how the internal atomic crystal structures are deformed to bring you the real shape and to have the memory effect. So how the performance is, like, apart from this, this is predominantly used in medical field. If you have a head injury or some operation in the brain, they will remove the skull. So then the skull can be made using of shape memory alloy, because it is not a corrodable one. So it can be refilled exactly at this location. You can give a shape, perfect shape. And glass frames. Nowadays, many endoscopic based operations can be, now people are using this kind of memory alloy. These applications can be used, and it is available in the form of rods and wires, etc. etc. things. Now, when you have different materials, obviously you will try in RCC structures. So it has wonderful recentering capacity. That is called recentering capacity. When you apply a stress, it comes to its original position. That is called recentering capacity. So we have one of the study has been focused on how to use this particular material as a damper. Because damper, the role of the damper is to dissipate the energy and try to bring back to its original position. So this SMA has its own inherent property that is called a shape memory effect, and it's called recentering capacity. So they have trend, but the SMA is not an energy dissipating device, but it has a capacity of recentering. So in an additional damper, in an existing damper, you can use this particular device so that it will try to pull, a damper can dissipate, this SMA will try to pull it back to its original. So it's a combination of things. So similarly, they have tried with bridges and some church towers to rectify this. Some bridge pier they have understood, they have conducted the study. So one of the study has been done exactly at the beam column joint to study its behavior under cyclic loading. Exactly in the joint region they have used SMA. So this is how it has been corrected. The stress strain behavior, you can see the conventional stress strain behavior of rebar is like this. The stress strain behavior of your SMA is like this. So modulus is very small, and energy dissipation is obviously very small, like this. So they have tested under cyclic load. This is the conventional one. This is a shape memory alloy. So it tells you, SMA is telling you that I can able to recenter your beam column joint, but I don't have the capacity to dissipate the energy. So it has less energy dissipation capacity, but it has a capacity to recenter the beam column joint. You can see the conventional beam column joint failure. This is shape memory alloy failure. So it brings back to original position and experience similar cracking like conventional. That's it. So this is the capacity of your shape memory alloy based beam column joint. So it will not allow you to dissipate energy, but it can try to bring the beam column joint back to its original position. So next one is called FRP wrapping. FRP wrapping is everybody knows, and everybody may tell you that, sir, we know about FRP strengthening. So I won't much more focus on this. I will focus only on pre-stressed FRP. FRP, everybody knows what is FRP, is a fiber reinforced polymer. Polymer means the epoxy we are using to strengthen. It is a performance-oriented material because instead of going for RCC jacketing, you can use FRP, thin FRP, which will not increase the cross-sectional size of your RCC structural elements, and without increasing the cross section, you can increase the stiffness, strength, but you can't increase the ductility. That's not possible using FRP in beam strengthening. When you use number of layers, you are increasing the strength, not ductility. That's the limitation of FRP. In column, generally in column, we are experiencing when we apply uniaxial force, it becomes a biaxial. But when you use epoxy, when you use FRP, it becomes a triaxial. When you apply axial force, the concrete will try to split horizontally. That is called another force called biaxial. But when you use FRP wrapping, it gives you another force inwards, which is called that's why it is generally termed as a triaxial force is happening when you wrap FRP in columns. So another additional application is called near surface mounting. If you want to increase the flexural capacity or shear capacity, instead of using FRP wrapping, you can just make a groove and you can use FRP plates or FRP rods with epoxy. This is called near surface mounting technology. So field applications they have used in different technologies. There are many practical applications. Nowadays, it's predominant in our country. If you want to increase the capacity, you can use a FRP score. Just use FRP, that will be good. No, this is not like that. If you are using FRP, it should be perfectly designed. Otherwise, FRP strengthened portion becomes more stiffer and more high strength compared to the unstrengthened portion. So failure will focus on the weaker point. So your strengthened portion will become solid enough, but weaker point will have you severe distress. So when you are using FRP strengthening, the entire building has to be redesigned perfectly so that you can safeguard the structure. So in FRP strengthening, this is how the conventional strengthening will be. In almost, if you look at the FRP studies, failure of FRP will be in terms of delamination. Because modulus capacity of your CFRP is very, very high compared to the glass. So glass generally will rupture. So predominantly CFRP is preferred in strengthening purposes like this. When you do strengthening like this, when the element is subjected to a large amount of lateral force, monotonic, etc., etc., the fiber will take the stress up to a certain limit. Later, the interface matrix, the epoxy, loses its strength, bonding ability, and it will not transfer the force to FRP, and the FRP will delaminate. FRP will delaminate because the epoxy which we have used is not able to transfer that much amount of force. So the FRP generally delaminates because the combinedly it can able to take the load, but we are not able to use the efficiency of the FRP to a maximum extent. We are not able to use. So the way is important in FRP wrapping is its anchorage. So similar to the fiber reinforced concrete, here also the anchorage, end anchorage plays important role. So when you are doing U wrapping like this, exactly at this point we have to do end anchorage like this. They got an end anchorage. You can see end anchorage will be like this. So this is nothing but we have to roll the FRP and then we have to insert some FRP plate or non-corrosive plates, any plates, and then it has to be anchored with the beam using some mold. So when you are anchoring like this will not allow the FRP to delaminate, number one. So for example, if you are using without delamination, so without, for example, this is called unstrengthened. This is strengthened. So the strength is increased, but delamination occurred. So when you are using external anchorage, it becomes like this. So similarly, when it comes to a pre-stressed of FRP, same can be attained using pre-stressed FRP. So this is this is for pre-stressed FRP. When you are using FRP with external anchorage, this will go like this. So you can increase the efficiency further. So another advancement in the FRP system is called pre-stressed FRP. What is called pre-stressed FRP? Pre-stressed FRP means, I told you, we have to use end anchorage so that we can able to increase the efficiency of your FRP in shear. When it comes to flexure, same thing, we have to go for end anchorage. But when you simply place FRP, the performance can be increased. But when you use pre-stressed FRP, the performance can be further elevated. Even a deformed beam, a certain amount of deformed beam can be taken to original shape by using pre-stressing methods. Pre-stressing steels or pre-stressing FRP. FRP sheets can be pre-stressed or FRP plates can be pre-stressed. So when you pre-stress, when you apply a pre-stress, Same kind of pre-stressing concrete principle, but we are using FRP instead of pre-stressing normal strands. So when we use FRP pre-stressing, so this is how these are the instrumentation used to pre-stress that. Pre-stressing is nothing but we have to make the anchors, and FRP plates will be placed with epoxy, and then there is a jack will be there. The jack will be jack will be used to pull the FRP to a certain extent. By using the pressure gauge, we will measure the applied pressure, and then it will be stick together. It will be anchored. This particular thing is for anchoring. This is for anchoring purpose. This is for anchoring purpose. This is for applying the pre-stress purpose. So once it is pre-stressed, it will be anchored together. So you can see here, they are applying the pre-stress, and once the pre-stressing is fixed, it will be anchored using this bolting arrangement. So it is perfectly anchored. So in the next day, you can remove the extra portions. So this is fine. So this is called pre-stressed FRP. So predominantly it is being used in our nowadays in our India. Also we are using this in bridges, in buildings having long span. So you can use this kind of things because it is non-corrosive. So externally it can be exposed to atmosphere also, and the pre-stressing option gives you a certain lot of savings. There are no need to use large number of layers, can be reduced, and efficiency is also increased to a drastic level. So these are the advantages of pre-stressed FRP. Next one is called base isolation techniques. So this material here we are using different type of materials, are steel, rubber, or rubber with copper. Many things are being used. The building remains as it is. Only the foundation to building connection has been dismantled, and they have used base isolated. This is called isolated bearings. When you are applying lateral force in terms of inertial force, the building will deform like this. When the same inertial force happens, the building will deform like this, but your base isolation deforms. So the base isolation deforms and takes all the energy and dissipates all the energy. Base isolation is not allowed for tall story buildings. It has a certain amount of limitations because when the tall story building is subject to a large amount of wind force, it has large amount of modes, large number of mode shapes will be there. So the base isolation is restricted for a certain height of the building. It's not for. So how it works? When you are using the base isolation, it will generally is not allows the building to vibrate. So building is not subject to a large amount of lateral forces. All the lateral forces are beared by the base isolator bearings and dissipates the energy by deforming. So in order to take the gravitational force, they are using lead plug, and in order to take the lateral force, they are using the rubber layers with stiffening plates. So we have to use this bearings exactly at the ground story. Sorry, not at the ground story. Between the foundation and the superstructure connections. These bearings are many types. One is elastomeric bearing, roller pin bearings, and ball bearing. So according to the demand and the requirement, we have to choose the right bearing, and we have to use the right bearing for the purpose. So apart from this, we have another material called isolators. These are the different type of isolators. Next one is called active damping system. You may ask me, what will happen when it goes to a large tall story structure? Tall story structures are subjected to a large amount of wind force than earthquake forces. Every day, the building is subjected to a wind force. So when you are constructing a tall towers, 100 story, 200 story, 50 stories, then those buildings, if you conventionally design the building, using brick, concrete, etc., thing, what will happen? The ground story beam will be depth of your ground story will be equal to the depth of your ground story itself. So it is very difficult. So we have to reduce the self height of the structure. So generally when you are going for a tall structures, we are not using brick wall, concrete wall. No, there are no concrete wall, there are no brick wall. So we used to have a dry wall panels, which is made using some cement plaster board or fiber boards, and internally the wall will have a vacuum space or some filler materials, foam-based filler materials, or glass wool-based filler materials. So that will give you thermal comfort, soundproof, and but it won't take load. It won't take load. So load will be taken by the frame, and these wall panels are acting as a that's it. In such cases, we are reducing the self-weight of the structure. So when you don't have that much of self-weight of the structures, the structure is subject to a large amount of wind force. So it will deform. So in order to address all forces, they are using active damping system at a desired level of the building. So when the building is subjected to a large amount of wind force, the dampers immediately start to work and receive the energy and dissipates the energy. It will not allow the frame to take the energy. Frame will receive, and all the energy will be transferred to the damper, and the damper will yield, and it will receive. The damper will yield. Damper should yield. If you are not designing it properly, if you are instead of damper yielding, if your frame yields, then there are no use of using damper. So the damper should yield, so that through that yielding it will dissipate the energy. A damper may be of many types: viscous damper, steel plate damper, X damper, frictional damper. So when you use damper with base isolation, this is also combination is possible. So damper, instead of damper, you can use bracing, only normal bracing using the steel angle, steel plates. That is also possible. So these are the slit metallic damper, in which you will have a steel plates like this. Steel plates will be in the form of I shapes. Okay. So generally I is meant for take the shear. Okay. So this portion will take the shear force exactly, and it will, but it is very small in shape. So what will happen? It will deform and it will take the shear force. So generally this web plate is generally meant for taking the shear force, and this is to support the moment force. So these are the this is how it has been installed in the structures. These are the various types of dampers available and never being used in tall story buildings. So when you are using tall story, when you are using this kind of dampers in the tall story building, you can reduce the vibrations because of wind force, and then we can reduce the deformations because of wind force. Because tall story structures are subjected to a wind force than earthquake forces. So it is must to encounter the forces. So these are the various ways of providing damping devices to control the vibrations. So yeah, this is what I was missed. This is the continuation of the self-healing concrete. So the capsules will be like this. It will be plastered like this, cement mortar plaster. Okay, and then it will be mixed with concrete. So you can see here. So now they have applied the axial flexural load. So it is getting cracked. This particular adhesive is getting leaked through the cracks. You can see in this image. So it is the crack, and the things has been broken, and it has completely filled the cracks. Once it is exposed to sunlight, or if you feel that internally my internal house, the beam in the internal house is getting cracked, and if you see the adhesive, we have to apply the UV light. Once you apply the UV light, it will mature and it will bridge the cracks. So actually it should be the continuation of the presentation. Unfortunately, it is misplaced. So I would like to conclude my presentation by this. I'm so happy to have questions from you. If you have any queries, please ask me. I will try to explain.
Yes, sir. Thank you very much for your wonderful presentation, sir. And I request all the people who can raise the question. Before that, sir, the cost of the material, because whenever we are going for high performance material, we should not talk about the cost. But even though for the curiosity, I am asking that. So at the last end, you are telling that a capsule thing we can able to insert. If any cracks comes, it's agent it will indicate. Then whether it's came to our normal commercial area, sir, even a common man can able to.
That's why I told you it is still in the under
because
previous there are lot of limitations are available. So now it will be probably it will overcome, because beam, suppose if it is a beam you are expecting to crack in its lifetime, it may take some time. So even a beam may crack after 30 years. So till the 30 years, the chemical should be able to sustain. generally it won't sustain. The chemical will not have that much amount of sustainability. So it is very difficult to. So now a lot of researchers are moving. So we can expect in future such kind of chemicals.
Okay, sir. Okay, sir. Then because so far we are here about only that bacterial concrete in the name of self-healing, and this is a new one that is based on the capsule.
I have an opinion. The bacterial concrete will fill the gap, will fill the gap, or will fill the crack. Will it give you bond between two? Will it able to transfer the force from this point to that point? There's a lot of questions. So when it comes to a self-healing based these kind of adhesives will mature like an epoxy, and it connects the cracked portion together. So the structural strength of your bonding that adhesive will be higher than the concrete. So generally crack will not happen exactly at the connected portion. So you can expect the crack in the other portions where we are not using adhesives. So there are chances in future. Probably we will come to impact this.
Yes, sir. Dr. Rajiv Jain, sir, you can unmute yourself and you can ask your question to our keynote speaker. Dr. Rajiv Jain, sir. Yes, sir. His question is, what is the maximum size of cracks can be healed?
That's why I told you, this is actually for finer cracks. If you are expecting that during an earthquake, these capsules work, no. During an earthquake, if your building is subjected to a very fine cracks, then there are chances. Like no, cracks are margins. If you are expecting some micro cracks, then it can heal. But if you are expecting some major cracks, say I have a 2 mm of crack width. 2 mm of crack width is very difficult to fill using this kind of, because the sealant will come out completely. The sealant will come out completely. So that time it is only applicable for micro cracks. Only applicable for micro cracks, not for macro cracks.
Okay, sir.
No, 2 mm I am telling you for an example, not for thing. I'm telling you, but if you have a 2 mm crack width, 2 mm crack width, probably the adhesives will completely come out. Completely, it will try to come out. So what we have tried in our case, in our laboratory, we have tried we have applied a small amount of thing, and we have applied epoxy injection in against the gravity. So after injection, we have broken the sample and we have checked the thing. So when the crack width is very high, then the epoxy injection was working very perfectly. When the crack width is very fine, then the epoxy injection was not perfectly going through. So we got to go for another technique of injections. So that's why I told you, when you have very fine cracks, these kind of adhesives can easily penetrate into. But when you have very higher, say more than certain 1 mm or 2 mm crack, these adhesives will come out. These adhesives will come out from the crack, so it will not help you. So it should be very fine in nature, then it can work. Micro level.
Yes, sir. Sir, regarding the fibers, because yesterday session also we have coir fibers and natural fibers, and in concrete, because it's a biodegradable, so how can we go for that natural fibers? How much far we can go for natural fibers?
Generally, natural fibers will degrade. If you want to use natural fiber, you can go for bamboo, treated bamboo fiber. That will give you some amount of life than coir fiber. These coir fibers will.
What kind of treatment we have to do, sir? Treatment in the sense what we have to do.
I'm not the chemist. I never done any polymerization. So I have just simply used and observed its performance. So treatment will be they have to use some polymer treatment. They have to apply. I don't know exactly the treatment in the reference.
Okay, sir. Because
in the market itself, it is available with the treated. If you want to use bamboo for your buildings, we have to use a treated bamboo, so that the termite attack will not be there, any other fungus attacks will not be there. So similar kind of treatment has to be done.
because recently we have seen that reinforcement can be replaced by the bamboo sticks or bamboos level as it is. So in that I am raising the queries whether it is a biodegradable, how far it will be there. That is the thing, sir.
So bamboo, you can replace the reinforcement just for earthquake bands. If you are talking about earthquake bands, you can replace the normal reinforcement, and that will give you wonderful integrity. That will give you wonderful integrity. That's it. But if you think that my entire building will take, no, we have tested few beam tunnel joints with bamboo, so it can give you good amount of energy dissipation. But probably because when it reacts with cement, obviously it will get degrades. So it is only applicable for non-structural elements. Non-structural elements can be done. If you are expecting that complete replacement of reinforcement in our conventional RCC frame by bamboo, is not possible.
Okay, sir. Thank you, sir. Any other questions from participants? Yes, any other? I think there is no questions from participants, sir. Anyhow, thank you very much, sir. On behalf of our SR Engineering College management, faculty, and the students, I place my sincere gratitude to you for accepting our invitations. And there is one more queries came.
Yeah.
Okay, sir. That's not that's a FDP query. So, sir. Anyhow, sir. Thank you, sir. Thanks for joining us, and you are sharing your valuable knowledge. Thank you, sir. Thanks once again, sir.
Thank you so much. Thank you so much.
So, dear participants, I think so many queries regarding that is feedback and attendance. Let me clear in this. It is a clear directions I got from that ATAL-FDP-ACTE. They are telling that you should not share the attendance or any links to in the WhatsApp medium or platform. I have to give everything in the chat box or to communicate through that mail. But if I communicate to that through mail, that may some people's may misuse, because some people they are not attending and they are directly will do for the things. So here I am giving that the link once again. Anyhow, morning we are giving. Yesterday what happened since morning we given, afternoon also we given. Even in the evening also again all the combinations of 3 links we given. So in this regard, if you face any issues, some people, Mamata madam is asking that the chat box, the details, it's getting deleted because of the net issues. Okay, no problem. If you message me or send me, definitely we will give that link only for that those who ask. Because again and again, if I am placing that, some people are copying that link and they are pasting in some other thing, and that should be avoided. And another madam from Suicide is may get day 2 session 3rd link, please as mentioned. Yes, madam, you can message me separately. We will give it, and we will check it whether you attended on that day. If it is really there, we have attendance everything. We will definitely give that link, madam. So there is no issues in this. So any other issues in this, sir? Any other issues? And I hope you are aware of that. That is 80% of attendance is mandatory, and 60% of assessment also is there at the end of the day. Hope you are making everything as a noted one. I am sharing all the PPTs what they have. So far I received what are the PPTs. I am sharing that. Still I am asking to our keynote speaker. They told that I have to curtail or I have to tailor something. After that I will give you, because some of the data they have for some government things, so they want to curtail some of the things and they will give you. So that times I will give all the things. And today I am going to upload the entire videos. So far we have seen so many lectures. Right now we are in the 7th sessions. So all the sessions I will upload in the YouTube. So that link I will share you. So today also the live streaming in the YouTube also is there. So this session also in the midway, the session was streamlined in the YouTube. So you can get from that also. Is there any other thing, sir? I hope you received everything. And so again they are asking, please repeat about the attendance and feedback. Okay, today's sessions you are asking. I think we will repeat that. It's not a problem. Recently, some people are joined that today's sessions feedback. Today's sessions feedback link already given. Once again, we will post it. It's not a thing. We will post it in now itself. And if you want, I will not close this meeting. Just for 5 more minutes, we will open this and we can take that. So now the link is shared. Today's morning session. We can take it, sir. Session 1 feedback for today's 3rd day. I have joined the WhatsApp group in today's session. Feedback is given. They are asking that. Okay, sir. Any other things? You can message in that. We have a WhatsApp group. You can ask anything in that. Okay. So whatever regarding the FDP, we will ready to address immediately.
Sir, I have not joined in the WhatsApp group. For the last 2 days, I'm asking about it.
Sir, I given the link, sir.
Shall
I given the link.
Sir, I didn't get the link. Shall I post my number?
Yes,
so
sir. Yes,
that
sir.
I can able to join?
Post the number, sir.
Yeah, I'll do it, sir. I'll do it. Last 2 section also I was asking about it. I didn't get
yes,
that.
Sir, I have. So you mailed. Yes, right. I have remember, sir. So 9176 917.
Thank you, sir. Thank you very much.
477 171.
Yeah, yes, sir.
Yes, sir. So okay, sir. Vijayan Shiva, sir. I will add it, sir. I will add, sir. Yes, sir. I will add, sir. I will give the link. You can share. You can add, sir. Yes, sir. Any other, sir?
Nothing, sir. Thank you, sir. Thank you, sir.
Yes,
Thank you very much.
Rajiv Jain. Yes, Rajiv Jain, sir, also asked that. Okay, I will make a note of it. 9425 00 3796. Okay, sir. Sir, any other, sir? Okay, sir. Did you copy today's Google form for attendance and feedback? Shall I close this? Yes, sir. So now time is 11:25. We have enough time. So 11:45. So letter 9:40. Everyone, I request all. 11:40. You be in your meeting area. So our Dr. S. Shankar sir is going to give a next session. The topic is use of marginal materials in low volume road construction. So Dr. Shankar sir from NIT Warangal is going to deliver the lectures at 11:45. So be at 11:47. Thank you, sir. Thank you.